Right, so we're going to do what we just did, except now with chemicals slash moles, right? So what we start off with is a chemical formula. Sometimes it's given to you, sometimes it's not. But either way, you need to start off with a chemical formula. So in this case, we're going to have 3H2 plus an N2 to form 2 NH3s, right? So just like our sandwiches, this can be considered our recipe. I don't know how to spell recipe. The main thing they need to do with these recipes or our chemical equations is always check that it's balanced. Right, make sure that everything on the left side shows up on the right side. In this case, it is balanced. And again, we have our stoichiometric coefficients, right? A 3 in front of the hydrogen, a 1 in front of the nitrogen, and a 2 in front of the NH3, which is known as ammonia. Those are stoichiometric coefficients. And they're always in terms of moles slash molecules. For our class, we'll be thinking about them solely as moles, but you can think of them as molecules as well, right? We need 3 H2 compounds for every 1 N2 compound to make 2 NH3s. But remember, moles is just a way of counting. So you need 3 moles of H2 combined with 1 mole of N2 to form 2 moles of NH3. So we can ask ourselves all kinds of questions. So for example, if we have 3 moles of N2 and excess H2, how many moles of NH3 can we form, right? And so we just want to pull out what we have from the question. That's our 3 moles of N2. And then we want to keep converting until we get to what we want, which in this case is our moles of NH3. So we have moles of N2, so we can go to our equation. Right in front of the N2, we see that there's nothing there, so it's just a 1. So N2 and N2 can cancel out. In this case, what we're interested in is the NH3. There's a 2 in front of it, so we're going to put 2 NH3. Do the math there, we can form 6 moles of NH3, right? You see, it's the same thing we did with the sandwiches, now just with compounds. What if we had 9 moles of H2 with some excess of N2? How many moles of NH3 could we form? Again, we're going to start off with what we have, 9 moles of H2. And then we can just use our chemical equation. In front of the H2, there's a 3. So it goes 3H2. If you want to write it out as a 3 moles of H2, that works as well. And then our NH3, we have a 2 in front of it. So we want to put a 2 there. This and this will cancel out. And the unit that we'll be left with is moles of NH3, which is exactly what you want. And then here you would type in your calculator 9 times 2 divided by 3. Either way, you should get 6 moles of NH3. Can ask other types of questions like, what if we want 6 moles of NH3? How many moles of H2/N2 do we need? So again, we're going to start off with what we want or what we have, 6 moles of NH3, and then start converting it into what we want. In this case, we want 2 different values, so we're going to have to do 2 different conversion units. In front of the NH3 is a 2. So 2 NH3 will go here. And then we just need to convert it. In front of the hydrogen is a 3. So we can do 3H2. Cancel, cancel. And then we're left with moles of H2. Go ahead and do the math. You should require 9 moles of hydrogen to make 6 moles of ammonia. And then how much nitrogen do we need? Do the same thing. 2 NH3 down here. And then in front of the nitrogen, we see that the coefficient is just 1. Cancel, cancel. And we left with the fact that we need 3 moles of N2, right? So very simple conversion units. Make sure that you're using this method, as these will get more and more complex. But if you use the method, none of them really get too hard.